Hi everyone, I'm Matteo Collina, and I'm here speaking today about GraphQL Accelerated. And yay, I'm very excited to be speaking here at Work From Home Conf. And whoa, okay, first conference that I'm speaking, this is fully remote, so well, we'll see how it goes. Please follow me on Twitter, is @Matteo Collina, and shout me any question you have. I'm also on the chat, so if you write something, it's on my right? So you can see that, and you can actually write me questions and stuff. I'll try to answer during the talk. So let's jump into it very quickly. So here we go. GraphQL Accelerated. We're going to talk about GraphQL. I hope most of you know about GraphQL, but here's a quick recap, if you don't mind. GraphQL was originally built to represent the full of, to build an API to represent the full of Facebook. In fact, so all the examples we're talking about are Facebook based. So you can, if you do a get of your Facebook friends, you will get some JSON out of this, right? So maybe, I don't know. And it's an array with a bunch of field objects with a bunch of fields. However, now the mobile app just wants to have only the names of your friends and not all the context. So what you do, we do get Facebook friends names. Well, of course we do, because the mobile app wants to save on bandwidth. So we want to do that, right? Or maybe we can just specify a filter name. All of this is non-standard, right? It's completely not something that you need to reinvent every time. Also, when we load an app, you might get that you want to get your favorite friend and your likes, and you need both of those pieces of information at the same time. You have your page loads. So to create the full experience of your app, you need to do both. So with REST, it's complicated. Should we issue 2 queries in parallel? What we do, even if we issue 2 queries in parallel, those 2 queries, we're going to have to use 2 connections, and maybe there's only 4, limits is 4, whatever, possibly complicated. So maybe we can do Facebook friends and likes. Oh, nice, 1 more endpoint. So, how many endpoints have we got? Once upon a time, I was working on doing the backend for a mobile app, and I had to simplify something like 150 API endpoints to maybe 5, something like that. So, well, GraphQL is born to fix all those problems and create a single way of representing this type of data. So you can send a query to get all the friends of Matthias and only their name. And note that this only returns the name of the friend. And how does this work? Well, this is defined using types. So so GraphQL is a typed query language that is defined, that is some schema definition. And this is our schema for our friends. So we can issue this query, which is friends. We accept a name string, which is the name of the person, and we return friends, and return an array of friends. This is a typo. Bad for me. Anyway, what it does is, and then you specify a type, and then you have all of those, and all of those are properties. So what you do is you ask for friends, but you can, with GraphQL, you can also issue 2 queries in parallel. And those will be returned as a single response to you. This is really powerful because it allows you to save a lot of round trip times, especially on mobile devices, but also on the web, where you need certain stuff information all arriving all at the same time to display it properly. So you can just issue 1 query and get all the data that you need. Know that you can also specify variables in your query, so you can actually define your query and have variables in there, so it's all simplifying. Note that GraphQL has a very rich ecosystem. In fact, it has fantastic. It has a huge list of things that you can want to go through. Now, if you load up GraphQL, you can, no, not GraphQL, you can actually go and find a huge amount of information here in the GraphQL.org website, which is owned by the GraphQL Foundation. And you have code, and you can actually learn a lot of things here. And know that there is spec, and this is the full spec of the GraphQL. Whoa! You can implement all the things you want. So there is support for it in all possible languages. Now, in fact, what I'm going to show you is one of the fantastic tools. So one of the stuff that we got is this library called Graphql. Graphql is a React component, but also a standalone thing that you can also embed. Because it's a React component, you can also embed it in your app. So either you define a query, we want all the starship in Star Wars, and for each starship we can want the name, the manufacturer, and the hyperdrive rating. And we can click, and you can see that we got all our data. Now, the nice thing about this is that if we open the query, you see that there is we can get a lot of things here. Now, note that we can also call all people that we know about, and we can ask for the people and their name. And here we go, we get all the people and that all the starship, and all these two queries are done in parallel at the same time. It's pretty cool. I really like the fact that most of this so GraphQL shines when I can have each individual team do when I can have each individual team create their own queries, essentially. So if my GraphQL type definition and my GraphQL schemas are powerful enough, I can have there is no more the concept of, oh, I need a backend for front end for this team and a backend for front end for this other team, because they need two different set of APIs and two different data models for doing their thing. With GraphQL, I can create one and then can assemble data as much as they need. So it's pretty cool. So let's go back to presenting this. So this is fine. One of the great reasons of this is it makes prototyping super easy. You have seen it. It just takes a second. I can test my query, run my query, and have a lot of fun in the process. So it's way simpler than using something like Postman for discovery and other bits, because, well, it has autocompletion, right? That's the thing. However, all this magic that you're seeing, all this fantastic autocompletion comes at a cost. And it does not come for free. It's essentially, if you look into the GraphQL, if you look into how GraphQL is built, GraphQL sits on top of HTTP, and it's another language on top. While if we were thinking of REST was actually working at the same level of HTTP, essentially. So it's giving meaning to HTTP concepts. So as every abstraction does, every abstraction has a cost, and GraphQL is no exception. And one of the things that we have experienced over a long time, actually, not the last few months, probably the last few years at this point, we have seen that GraphQL was underperforming compared to REST. And we started to investigate why. At Nearform, we have built this tool called Node Clinic. It's a nice tool to do performance analysis of Node.js application. You can find it at clinicjs.org. So here we go. Here is clinicjs.org. And there is me speaking here. Hey! So we have a bunch of tools. We have Doctor, Bubble, Flame. I'm not going to go deep into this. I'm just flagging. These exist. Check it out. And as part of this, how do you use it? Well, we use Clinic Flame, and this generates a flame graph, and then Node, our runtime, and then the file we want to run. This is an example built on top of Express GraphQL, which is a very popular module. And then we can do some load. For example, execute a query that adds two numbers. And what we have seen in in our flame graph, it's very interesting because in the flame graph, as you can see here, it spends a significant amount of time in a file called visitor, and it has entered. Why does this keep shifting automatically? I don't know. Okay. So this visitor is the visitor is actually a common pattern that is used to traverse an abstract syntax tree, and that's what GraphQL uses. So when you send a GraphQL query, the GraphQL runtime parses that query, generates a full abstract syntax tree, which is a typical concept of languages and parsers and so on and so forth. And this is a tree, it's a big data structure, and then it traverses it to do work. And you can see that all of this is passed here. Note what is very important is that it's passing this line this file called validate. Now, what it does is whenever we receive a request, GraphQL parses the query to produce a full abstract syntax tree to execute the query. However, it just do not traverse it once, but it traverses it twice. The first time for actually validating that the query can actually be executed against your schema. And the second one to actually execute the query itself. So essentially, it's a lot of data navigation of this very complex data structure that's actually costing a significant amount of CPU time. Well, we were not surprised when we started doing our analysis to find this. And in fact, we were thinking, well, how can we solve this problem? Well, in most cases, most teams are building both the client and the servers, right? And most of the queries tend to be kind of the same over time. So because most of the queries tend to be the same, in fact, we can just cache the abstract syntax trees. Like there's no point in doing all this work all the time. Okay, new query, let's parse it again, let's validate it again, and let's validate it again. So it's essentially it's a lot of work and a lot of complex data structures that are built for just being thrown away. Those can be cached. So what we tried experimenting on was to use an LRU cache, least recently used cache, to cache the stable queries. So queries that have been seen sometime. Note that if you want to check which implementation of LRU cache you should use, you can go to see this nice repo called bench LRU from Dominic Carr. Hi, Dominic. I don't know. We're probably sleeping at this point, but hey, Misha. And you can actually look at it, and you can choose the implementation of an LRU that you actually would prefer. Note that the most interesting number here is evict, and you want a balance between all of them, essentially. So anyway, going through, and they have different APIs, different properties, so you might want to make you can make an informed decision on the performance of this. So going back to the talk, here we go. We have built a prototype using Fastify. Fastify is a low overhead web framework that myself and a bunch of other contributors, mostly other contributors, in fact, have built over the course of the last few years. You probably see me speaking about this framework everywhere, so I'm not going to do too much of a pitch, but you can go to www.fastify.io and load it up and see where we are at. So it's pretty a nice framework, I would say. Anyway, this is it. It's a nice one, or at least I like it. Anyway, we have built something on top of Fastify to support GraphQL. So it's a library called Fastify-gql. and it implements this concept of caching. And how do you use it? Well, you instantiate it, you specify your schema, your resolvers, you register cars if you need cars, and then you use Fastify-gql here. Nice, right? So essentially what will happen is that you will expose schema and resolvers, and it will just work. Now, these are some benchmarks I did some time ago that shows a difference in performance between Apollo Server, Express GraphQL, and Fastify-gql. In fact, it's not just me that have proven those numbers. So you can actually, if you look at GraphQL node benchmarks, you can see that there are several independent developers that have benchmarked those, and you can see the result here, and you can see how good this is essentially. So for this specific use case, so pretty interesting. Check it out, and it's really usable to some extent. And the gap between Fastify and just a more bare-bone core approach is very thin. Anyway, going back to our presentation. Well, we have done some initial analysis using Clinic, and however, we found that there was still work to do. So we'll see that there was a lot of work being done in Fastify GraphQL, in the GraphQL thing, and there's still a lot of work being done in there because we were able to cache the validation, and so the parsing and the validation, but not the execution. So we're still traversing that full big AST. So what could we do to improve stuff, to improve things? Well, it's possible to do on-the-fly code generation. So essentially, instead of just caching, we could actually compile your query into JavaScript. How does it work? Well, this is an example. So if we just use the JIT, you will see that the number goes up even more. And you can see the JIT is implemented by this library called GraphQL-JIT. I didn't build this. We built a prototype of this. Then I've seen the folks at Zalando doing such a fantastic job that we just said, well, let's just use theirs. It's just so good. So just look at this. It's actually really nice. So check it out, essentially. And Fastify-gql use these internally. So hey, it's pretty cool. And I just wanted to finish that with using for something like Fastify-gql. It more or less offers, it's very competitive compared to Rest and other libraries because it has very little performance overhead compared to what it provides for you and the benefit of that GraphQL can do for you. So check it out. Let me know what you think. Open bugs. The URL of Fastify-gql is in here. Collina-Fastify-gql. And yeah, you can check it out. And it's here. It's a version 3.1.0 that I shipped 19 hours ago. Hey, it has a bunch of features. So long list of examples and a lot of options. It supports subscriptions. It supports being a client of Federation, but we're working on a bigger gateway as well. And there's a lot of stuff in here. So check it out, and I actually like working with it pretty much. So please let me know what you think. I just want to recap. I am technical director at at Nearform. So if you need anything, any help with Node, JavaScript, whatever, reach out to us. You probably see a lot of Nearform ads today, so some more. Here you go. Please follow me on Twitter at Matteo Collina. You can ask me questions at any time. I can try to reply to everybody. If I slipped, poke me again. I receive a lot of notification and questions, so keep me poking. And I think that's all. Thank you.